So good afternoon, all of you. Welcome to this lecture of applied thermodynamics. So last lecture we started steam condensers. Before going on, today we'll see a video of working of steam condensers. Okay. So this is not it. Just don't get confused. This is something different. Audio is not there. But it's not even required. There is only background music is there. How to erase this? Why we cannot? This is a condenser unit. This is the main part of condenser. There are the plates for the maximum heat transfer. Then there are the tubes. In these tubes, the water will flow, and these plates acts as a maximizing the heat transfer. Okay, so these are also called the plate heat exchangers because plate is there. Then the steam comes. Now you can see steam is coming. Heat transfer takes place in this portion, and then water is condensed. The condensed water is collected at the bottom. So these are the particles, nanoparticles. These are like for again maximizing the heat transfer. Strainer means it will strain the balls. So these are the plates. Okay, these are the tubes where the water will flow. It's a plate type of heat exchanger. So condenser, it is a heat exchanger. So this is a low pressure turbine bypass. Feed water heater. This is a feed water heater. Okay. This comes when there is a regeneration. We preheat the feed water. It's a hot oil where the condensate will be collected. These are the baffles. And there's the extraction pump to take out the condensed water. Okay. So we'll continue. Yesterday we have seen the definition, function, and the main parts of condensing unit. So let me just once again remind, this is the main condenser. So it has inlet of steam from steam turbine. Okay. Now steam will exchange with cooling water. Cooling water comes from cooling tower. So here we have cooling tower. Here we have condenser cooling water pump. This one CCWP. It will supply cooling water to this one. Water will flow through tubes. Steam will be thrown on these tubes. Steam will be condensated. It will be collected at the bottom. Then there is a condensate extraction pump. It will transfer this condensate to hot well. From hot well, again the water is pumped with the help of boiler feed water pump, and it is pumped to boiler pressure to boiler. Again, all the air or other particles, impurities in the steam are removed by air extraction pump. Again, if there are any loss in the water, because cooling tower, what happens? Evaporation of water happens. That is why there is a loss of mass of water. So in order to recover that, we have this makeup water unit. For that we have a makeup water. Okay. Any difficulty in this? Correct. Again, we have seen the classification. So there are mainly two types: jet condenser and surface condenser. What is the main difference between jet condenser and surface condenser? In jet condenser, there is a direct mixing of steam and water. In surface condenser, there is no direct mixing. There is a indirect. There is no mixing at all, but there is a heat transfer at the surface level. So that is why the name is given surface condenser. In jet condenser, we have seen types. This is a parallel flow. Okay, so this is a low-level parallel flow condenser because both the steam and water, these are flowing in the same direction. So that is why the name is parallel flow. Then next we have here counter flow. Steam is flowing in upward direction, water is flowing in downward direction. There is a heat exchange takes place, and that is why it is called as counter flow. Third we have, so this was the animation for the counter flow. Steam going in upward direction, water flowing in downward direction. Then we have high level jet condenser. Whenever this level of condenser is very high from the ground, at that case we go for high level jet condenser. And last we saw ejector condenser. Okay, in this case, steam is supplied. It is forced to flow in the central direction or axial direction. In this case, mixing of cooling water and steam takes place at the axial way, and we get the condensate water at the bottom. Okay, so that is why the structure is. There is again cross section is also shown. This is a cross section. Steam comes from this direction. It is forced in the middle section. Heat exchange takes place, and we get a condensate at the bottom. Then we have seen the advantages, disadvantages. Jet condenser is simple in design and cheaper, but in this case, the condensate water is not pure. Again, we have low vacuum efficiency. What is vacuum efficiency? We'll see later. Now, next type of condenser and very commercially used condenser, it is surface condenser. Okay. So what is a surface condenser? In this case, heat transfer takes place at the surface level. So that is why the name is given surface condenser. So in surface condenser, the exhaust steam and cooling water do not come in physical contact. Rather, they are separated by heat transfer bond. Hence, condensate remains pure and can be reused. So there was a disadvantage in jet condenser. Condensate was not pure because of direct mixing. So that can be removed by surface condenser. Okay. To see the construction and draw the diagram, first understand and then you can draw. Without understanding, if you draw, then there is no way. So there is this shell. This is outer part is called as shell. Okay. Then there are tubes. Okay. So that is why the name is given shell and tube type of condenser. So in this case, outer is shell, inside there is a tubes are there. Then there is an inlet to shell, outlet to shell. So in this case, cooling water comes in from the bottom. Here we have baffles which will separate the stream of flow. The water will flow to the tubes. It is directed this way and it is taken out. Now steam comes from turbine from top. It takes heat. Oh, sorry, it gives away its heat to this cooling water. It is condensated and then it is collected, or it is condensated to water and water is collected at the bottom. Okay. Very commercial and popular heat exchanger. It is shell and tube type of heat exchanger. Okay. Again, okay. Last again, if tubes are like this, then these are called as single pass tube. If tubes are connected like this, if the tubes are like this in this serpentine way, then it is called as two pass. So one pass, two pass, that is a terminology used in heat exchangers. So anyway, we don't require to be going into that much details. So you can draw this diagram. So this is a surface condenser, and that you can say it is a shell and tube type of condenser. Okay. Again, at the center, you can see there is an air extraction pump. So air is removed from steam, and that is why we get a pure condensate at the bottom. So please draw the diagram. Those are in online mode. Okay, completed. You completed. Good, good. So this is a cut section of shell and tube condenser. Now you can see here the inlet which we have shown already. You see your figure also. So there is an inlet. Okay. Then this water flows through these tubes, right? Then this water is again circulated and then again flows through these tubes and then it is taken out. So this is the inlet. This is the outlet for water. Then this is the inlet for steam, correct? Then there is a steam passes on this pipes, heat exchange takes place, heat transfer takes place, water, steam is condensated to water, and then we collect the water at the bottom. This is a cut section of a shell and tube condenser or a normal surface condenser. Now we'll see some of the types of this surface condenser. First one is downflow and second is central flow. Okay, so we'll see their theory one by one, but very detailed diagram is here. So first one is downflow. Why it is called a downflow? So steam and air, these are passed in downward direction, and here we have this tube section. Through these tubes, the water will flow. Okay, so this is a cut section. So water will flow perpendicular to this direction. So water is flowing through these tubes. Steam and air are passed onto these tubes, and then there is a upward direction is given. So first I move in downward direction, heat exchange takes place. Then there is a upward direction is given for this case. So here air is collected separately from this side, and condensated water collected at the bottom is collected from this side. So we have two separate pumps: condensate extraction pump and air extraction pump. So the direction is like this. The water gets, so as being heavy, it is collected at the bottom, and air is collected from side entry. So that is why it is called a downflow, downward flow, and collected at side level. Air is extracted lateral way. And second is central flow. In central flow, what happens? These are force. So steam and air first passes in downward direction, then they passes. Steam is converted into water. The water is collected at the bottom, and this air is collected from central direction. So initially, air was collected from this lateral direction, and in this case, air, this pipe, you may see it is circular, but it is actually passing throughout the heat exchanger. So the air is collected at the axial level, and this is air is extracted at lateral level or lateral way. So this is the difference: downflow and central flow. Okay. So first we'll see the theory, and then we can draw the diagram. So downflow: exhaust stream enters the top of the shell and flows downward over the tubes. Water tubes are double pass. The cold water flows in lower side first and then upper side in the reverse direction. So this cold water through the tubes, it actually flows lower side first and then upper side, which enables the maximum heat transfer. Okay. So in this case, the main difference in this case, both in this case, air steam enters from top, but in downflow, air is extracted at this junction, and in central flow, air is extracted from the axial direction. Okay. So just did I say something? What is the time? What is the time? 1. What is the time? Again, I'm asking, what is the time? What is the time? 1:30. So how many minutes you are late? So what should we do? Huh? What? Do you think it is a good sign? 34 minutes late. Why you are late? मेस मध्ये? अरे So now I should call mess owner. Huh? Our students coming late. What are you doing? See, this reason in my time also students used to give. When I become teacher, students are giving the same reason. So this reason is for therefore from last 10 or 20 years. Mess मध्ये करते होते. It is not a valid reason. We are also have been students at one time. Please take care. Next. Okay, downflow. Please don't draw this diagram. Draw this one. This is more sophisticated one. Downflow and central. Again, in MCQ examination, very less weightage is there for this chapter. Only 4 questions were asked last exam, but still you should know. More weightage is for the first section. So if you focus on first section, majority of the questions will be asked from that first section. The second section, majority of questions will be asked from reciprocating air compressor. Okay. So draw freehand diagram. No need to draw zigzag round shapes again. Huh? Draw. So you take condenser or evaporator, both are heat exchangers. Okay, heat exchange takes place. Okay. We'll see the central flow type. In central flow, steam flows radially inwards. Okay. So in first case, in downflow, steam directly came in downward direction and then the upstream. So passage was like this, steam coming in downward direction. Again, some change in direction was given to this steam. In the second case, steam comes in downward direction and then it flows axially inwards. Okay, this is a axially inwards. So I hope you are able to imagine. Steam is coming in downward direction and then it is going in axial direction. Okay, has anybody seen a centrifugal pump? So in the centrifugal pump, similarly, the inlet of water is radially inward, sorry, axially inward and radially outward. So in this case, similarly, steam flows axially. Okay, steam flows axially. The condensate collected at the bottom of the shell from where it is taken out by condensate extraction pump. So there is this condensate extraction pump. Steam gets access to the entire periphery of tubes, and thus a large surface area for the heat transfer is available compared to downflow. Okay. In downflow, what was happening? The steam was directly coming in downward direction. Okay. So compared to downflow, if you see here, the steam is flowing in axial direction. Okay. Axial direction मध्ये पाईपच्या मॅक्सिमम एरिया मध्ये स्टीमचा कॉन्टॅक्ट येतो आणि डाउनवर्ड फ्लो होताना पाईपचा पूर्ण एरिया युटिलाइज होत नाही. तुम्ही जर पाईपचा टॉप व्ह्यू बघितला तर तुम्हाला एक प्लेन सरफेस दिसतो टॉप व्ह्यू, पण तुम्ही ऍक्च्युअली जर फ्लो होत असेल तर तुम्हाला पूर्ण पेरिफेरीचा यूज करून घेता येतो. That's correct. If you see pipe from top, you will see only half part of it. So only half part will be utilized in downflow in this case, but in this type central flow, whole periphery of the tube can be utilized for the heat transfer. So this is a having better heat transfer in case of central flow. Now next is inverted flow condenser, but unfortunately there is no diagram. Is there in textbook or either on internet also? Inverted flow condenser, the steam enters the bottom of the shell and air extraction pump connected at the top. So in all the previous cases, if you see extraction pump or air pump is at the bottom, but in inverted, the air extraction pump is at the top. Steam flows upward first, subsequently returns to the bottom of the condenser. The condensate extraction pump is connected at the bottom of the shell to extract the condensate. So see, in first case, in downflow, extraction pump is at side. Then in central flow, extraction pump is at the central, and in inward flow, air extraction pump is at the top. So that is the difference in this case. Just give the title inverted flow condenser. This is a very special case of condenser. This is called as evaporative condenser. Okay. Now, what is the evaporation? So there is a difference between boiling and evaporation. Boiling is when the water reaches to saturation temperature. Suppose if we take atmospheric pressure, in atmospheric pressure 100 degrees Celsius with the boiling temperature. So water gets boiled, converted into steam. In evaporation, like if you take example, surface जरी mop केला तर त्याचं पाण्याचं पण evaporation होऊन जातं. So that is a different phenomenon. So in this case, evaporation means when we expose water to large surface area, because of difference in vapor pressure, the water gets evaporated. So if you see air, okay, so little bit advanced concept it is, but if you are able to understand, then no problem. If you see, this is a block of air, let us say, but in this case, pure air is not there. Again, in this case, we have air plus water vapors करेक्ट. तुम्ही जर ऍटमॉस्फेरिक एअरचं सॅम्पल कलेक्ट केलं तर त्यात तुम्हाला एअर तर सापडेलच, प्लस H2O सापडेल, वॉटर वेपर्स. अगेन यू विल सी सम particles. Okay, some particles will be there, dust particles or other particles will be there. If we neglect the dust particles, majority will be air and water. Okay, now when I say atmospheric pressure is how much? Yesterday we have seen 101.325. Okay, kilopascal. Okay, so when I say atmospheric pressure is 10.325, it is a pressure exerted by both air and H2O. Okay, so there will be a pressure of air, so this is called as partial pressure of air plus partial pressure of water vapor. So they both have partial pressure, their individual pressure. When we combine both, then we get a 101.325. So there is a difference between partial pressure of air and partial pressure of water, which causes the weather changes. तुम्हाला जे काही weather changes दिसतात, पाऊस पडतोय किंवा ड्राय होतोय किंवा वारे येतात तिथे, पाण्याचं इव्हॅपोरेशन होतंय समुद्रात वर जाऊन ढगातून परत पाऊस पडतो. हे सगळे काय जे काही नॅचरल फेनॉमेना आहेत, it occurs only because of the difference between partial pressure of air and water. Whenever partial pressure of water reaches its saturation pressure, then water gets condensated. Okay, so there is another term which is called as saturation pressure. Saturation pressure. So whenever this partial pressure of water reaches its saturation pressure, then water gets condensated. So similar, so you can search in detail also, like how weather is created, how this flow happens, why monsoon is created, how we get rain, etc. If you go study in detail, it is all linked to partial pressure of water. Okay, so whenever partial pressure of water is less than saturation pressure, in that case no problem. Whenever partial pressure of water vapor reaches to its saturation pressure, in that case water gets condensated. म्हणजे पाऊस पडण्याची जी प्रक्रिया आहे, तर त्या केस मध्ये वेदर मध्ये partial pressure of water has reached to its saturation conditions, and then water gets condensated, and then we get the rain. Okay, so that is the concept of saturation or partial pressure. So similar concept is applied in the evaporation. So we'll see that the evaporation of some cooling water provides a cooling effect, thereby steam condenser. So see here, there is this water which is coming from cooling pond, and it is sprinkled with the help of this nozzle. So it is sprinkled on these tubes. Now in these tubes carries the steam. So steam enters from this inlet, and there is an outlet to steam. So as the steam flows, it gets or it rejects its heat through this sprinkled water. It gets converted into condensate water, and this condensate water is collected at the outlet. So the sprinkling, आता तुम्ही उन्हाळ्यात जसं आपण कूलर लावतो, म्हणजे एसी नाही, कूलर मध्ये पण सेम प्रिन्सिपल असते. कूलर मध्ये काय असतंय? So if you see the construction of cooler, so at the your face we have a big fan, बरोबर? So there is a fan at your side. दिसत नाही काय? Okay. So I will draw somewhere here. So at your side or your face, you have big fan. Okay, but at the back side we have this porous structure or porous membrane. On this porous membrane, so there is a water pond is also there at the top. Continuously water is dripping. Okay, so water drips in this porous membrane, and this fan causes a draft. We have the negative pressure तयार करता. That is why air flows in forward direction. Okay. Now, as air flows, this air also carries the water particles with it. Okay, and this effect is called as evaporation. So water particles get evaporated from this porous membrane, and then we have a mixture of air and water. So that is why the cooling effect is produced. Because of evaporation of water, cooling effect is produced, and then we say that it is comfortable to use air coolers in the summer. Okay, but if you see प्रॅक्टिकल पॉइंट ऑफ व्ह्यू आपलाच एरिया जो आहे सोलापूर असेल ते ड्राय एरिया जे आहे जिथं ह्युमिडिटी कमी असते त्या एरियातच वॉटर कूलरचा वापर होतो कारण त्या एरियातच तुम्हाला जास्त ह्युमिडिटीची गरज असते ऑलरेडी ह्युमिडिटी कमी असल्यामुळे वी वॉन्ट टू इन्क्रीज द वॉटर कंटेंट ठीक आहे तुम्ही जर एअर कूलर मुंबई किंवा चेन्नईत लावले तर ते इट बिकम्स वर्स बिकॉज ऑलरेडी ह्युमिडिटी इज more in humid areas like Mumbai or Chennai. In that case, you don't want to increase further the humidity. In that case, what is suitable is normal AC. आपल्या घरात जे नॉर्मल स्प्लिट एसी असतं ठीक आहे त्यांचं काम असतं कूल करणे प्लस डिह्युमिडिफाय मीन्स टू रिमूव्ह द मॉइश्चर सो नॉर्मल एसीज आर प्रिफर्ड इन कोस्टल एरियाज लाईक मुंबई चेन्नई एक्सेट्रा बिकॉज दे रिमूव्ह द मॉइश्चर and in our area like Solapur or Rajasthan already humidity is less so we want to increase the humidity so that is why we use water coolers or air coolers okay so this sprinkling creates a cooling effect and the steam gets condensed and it is collected here again there is an exhaust fan is or induced draft fan is installed at the top so it creates a flow of air in upward direction so there is a air is coming from downward direction and it flows in upward direction. So you can see there is a water sprinkling, there is air which is moving in upward direction. So both will increase the heat transfer and this steam will be converted into water. So our final aim is to convert steam into water and all this is to increase the heat transfer between steam and water. Okay, so draw the diagram. So all these cold storages in our area, they make use of such evaporative condensers. So we are going to visit one of these cold storages. I already discussed with HOD sir with plan. And there you can see such condensers are there. So water is continuously dripping on those condensers and the cooling effect is produced. Okay. So let us see some of the advantages of surface condenser. So high vacuum efficiency, pure condensate. So what was the disadvantage of jet condenser? The condensate was not pure because of direct mixing. So here we will get pure condensate. Low quality cooling water can be used. So for the cooling purpose, we can use low quality means because there is no mixing. As there is no direct mixing, we can use low quality cooling water. It allows the expansion of steam through a higher pressure ratio. So higher pressure means the pressure of boiler divided by pressure of condenser. That is the pressure ratio. So it allows the expansion of steam through a higher pressure ratio. Means higher the expansion, higher will be the work ratio, higher will be the efficiency of the plant. Okay, disadvantages, large amount of water is required. So as it is a surface condenser, we make use of cooling water. In that case, large amount of water is required. This construction is complicated. So you already have seen there is a shell and tube structure is there and it is very complicated. Costly maintenance and skilled workers are required. So there is a whole department is there for heat exchangers. If you see, there are some professional courses are also there for boiler and heat exchangers. So it has costly maintenance and skilled workers are required, and it requires large floor area. So these are the disadvantages. But if you want to increase the efficiency of the plant, then surface condenser are always recommended. So they allow the expansion of steam, higher expansion of steam, and that way efficiency of the plant increases. Right. Okay. So I will written. So in case of condenser, see, the pressure or inside the condenser, it is assumed that there is a steam is flowing and steam is condensated to water. So pressure of condenser, it is assumed to be equal to steam pressure or pressure of steam. Okay. Now in this case, what happens? Sometimes there is a air leakage. Okay, air gets flowed with the air or along with steam, and inside the pressure. So whatever if you have the pressure equal to steam pressure, it is called as ideal pressure. It is called as ideal pressure because there is no air leakage. If air leakage is there, then the pressure increases to PS plus pressure of air. Pressure of air. And this total it is called as actual pressure. So ideal it is only steam. If you take into consideration air pressure or there is leakage of air into steam, then it is called as actual pressure inside the condenser. Okay. So whenever we say vacuum efficiency, okay, vacuum efficiency in this case it will be equal to the barometric pressure, what you measure with the help of pressure gauges, minus the actual pressure. What is the actual pressure? PS plus PA divided by PB. Again, barometric pressure measured with the help of instrument minus ideal pressure, that is PS. So, if there is no leakage in a condenser, that means this air pressure will be 0, and then we'll get PB minus PS divided by PB minus PS, that will be equal to 100% vacuum efficiency. But always there is some air leakage in the condenser, so that is why it will be not equal to 100%. Okay. But with the help of these surface condensers, we have high vacuum efficiency. That means there is a less chances of air leakage. So that is why the vacuum efficiency is more in the case of surface condensers. So if you want to write down this vacuum efficiency formula. Barometric pressure, PB stands for barometric pressure, which is measured with the help of barometer, minus actual pressure. So PS plus PA is actual pressure in the condenser divided by PB minus ideal pressure, that is PS. So barometric pressure is absolute pressure, which is measured, the datum is 0 Pascal. PS and PA as the gauge pressure. Okay, please again I will clarify your doubts. PB stands for absolute pressure. So in last lecture you can check the diagram. Absolute pressure is measured from 0 Pascal datum, and these are the gauge pressure. So gauge pressure is measured above atmospheric pressure. Okay. Now there is this question which is always asked in or used to be asked in offline examinations: the distinguish between surface condensers and jet condensers. Okay. So let us see the differences between these two. So in this case, the main difference is cooling water and steam are mixed up together. And in this case, these are not mixed up. Okay. Okay. Next, it requires small space, floor space in jet condenser. In surface condenser, which requires large floor space. In jet condenser, the condenser cannot be used as a feed water to boiler unless it is free from impurities. So here impurities are present because of direct mixing. Here there is no such question because there is no direct mixing. More power is required for the air pump, and in this case, less power is required for the air pump. Less power is required for water pump. In this case, more power is required for the water pump. So in this case, there is a direct mixing, and it's in this case, large tubes are there actually in the surface condenser. In order to pass this water through these tubes, it requires more power. Okay. It requires less quantity of cooling water. It requires large quantity of cooling water because surface condensers are used for large applications only. It is a large heat transfer करायचा आहे त्या केस मध्ये surface condenser वापरतात. त्यामध्ये जास्त power देखील लागते and it requires large quantity also. The condensing plant is simple. In this case, condensing plant is complicated. Number of parts are there in the surface condenser. That is why it is complicated. Last, less suitable for high capacity plants due to low vacuum efficiency. Low vacuum efficiency means there are high chances of air leakage. More suitable for high capacity plants as vacuum efficiency is high. Means there are less chances for air leakage in the system. So in the your ISC 2, this question definitely will be asked. So I'll share this PPT in the study material sheet. From that you can follow. Okay. Now this point we already covered, effect of condenser pressure on cranking efficiency. So in order to increase the efficiency, what should we do? Should we decrease the condenser pressure or increase the condenser pressure? Decrease, right? So we have seen there are methods. Either you decrease the condenser pressure, or you increase the boiler pressure, or you superheat the steam, or you can go with reheating the steam and regeneration. So there are methods for increasing the efficiency. One of them, it is decreasing the condenser pressure. So this is related to that. So lowering the condenser pressure will increase the area enclosed by the cycle on TS diagram, which indicates that the net work will be increased. So previously net work was this much only inside the diagram. This was the net work done. As we decrease the condenser pressure, we can see there is an increase in area. So this will be new area. Okay. As net work increases, efficiency of cycle also increases. Lowering the back pressure causes an increasing moisture content in the steam leaving the turbine. So that is the drawback. Initially, at the outlet of turbine, we had dry saturated steam at point number 4. But if we decrease the condenser pressure, point 4 dash lies in the wet region. So here we have some moisture content. The moisture content is not desirable for turbines. Increasing moisture content of steam in lower pressure stages, there is a decrease in efficiency. Erosion of blade. Blade means blades of turbine may be very serious problem, and also the pump work required will be. Okay. So this point we already covered in the vapor power cycle. Lowering the condenser pressure increases the efficiency of the plant, but also increases the moisture content in the steam. Anybody have any doubt in this? Okay. Now, next is our last point here. It is vacuum creation in condensers. So condensers mostly work on at vacuum pressure that is below atmospheric level. So when steam condenses in a closed vessel, the vapor phase of working substance changes to liquid phase. Thus, its specific volume reduces to more than 1000 times. Specific volume म्हणजे काय बघा? Specific volume means meter cube per kg. Okay, means if you take 1 kg of water, how much volume it is occupying, that is measured by specific volume. Now if you go to the vapor phase मध्ये काय असणार आहे? Specific volume is very high. म्हणजे 1 लिटर पाणी तुम्ही जेवढं बॉटल मध्ये बघता, जर तुम्ही समजा इव्हॅपोरेशन केलं, बॉइलिंग केलं, 1 लिटर पाणी घेतलं, ते तुम्ही बॉयलर मध्ये टाकलं किंवा पातेल्यात टाका, त्यातून जी स्टीम तयार होईल, त्याचा जर तुम्ही व्हॉल्यूम मेजर केलं, so that volume is very much big compared to that 1 liter of water. That means when liquid is evaporated, the specific volume increases. When the vapor is condensed to liquid, specific volume decreases. Okay, so that is meaning of specific volume. Now, due to change in specific volume, the absolute pressure in the condenser falls below atmospheric pressure, and a high vacuum is created in the condenser. This minimum pressure that can be obtained depends on the temperature of condensate and air present in the condenser. How much below pressure we can achieve? It depends on temperature of condenser. Then the absolute pressure in the condenser, how to calculate? Atmospheric pressure minus vacuum gauge pressure. Okay. So already we have covered in the first lecture only. If this is a absolute pressure line, and if this is a vacuum atmospheric pressure line. Okay. So this is atmospheric pressure, and this is a absolute pressure. Okay. The pressure is below atmospheric. This is called as vacuum pressure. Okay. What will the pressure at this point? How to calculate pressure at this point? Absolute pressure. Sorry, what is the total pressure at this point? Atmospheric pressure minus vacuum pressure. Okay, this much minus this much, you will get this much, and this much is absolute pressure at this point. Okay, so that formula is given. Absolute pressure in the condenser is atmospheric pressure. This atmospheric pressure minus the vacuum gauge pressure. Whatever vacuum gauge pressure is measured, if you minus, you will get the absolute pressure at the okay. Okay. Now we have seen in vacuum efficiency, as the vacuum efficiency is calculated based on the air leakage. If air leakage is less, vacuum efficiency is higher. If air leakage is more, vacuum efficiency is less. So where the air leakage takes place, the ambient air leaks to the condenser chamber at the joints and glands which are internally under pressure lower than the ambient. आतलं pressure ambient पेक्षा कमी आहे. So naturally air will flow from high pressure to low pressure. Another source of air is the dissolved air in the feed water. So bubbles are there. This dissolved air in the feed water enters into boiler and it travels with steam into condenser. So these are the sources of air leakage. What is the effect of air leakage? The presence of air lowers the vacuum in the condenser. Thus, back pressure of the plant increases and consequently the work output decreases. It increases the pressure in condenser and that is why work output is decreased. Next, air has very poor thermal conductivity. Hence, the rate of heat transfer from vapor to cooling medium is reduced. So this may be another new concept for you, thermal conductivity. So in short, I will tell you, if you take a brick or a wall, if there is some temperature is here, let us say 400 Kelvin, and there is temperature here, it is 300 Kelvin. Okay. Now, how fast this heat will flow from this point to that point, it depends on its property. That is called as thermal conductivity. That is denoted by small k. इथं जर तुम्ही स्टील बार घेतला तर तुमचं कमी वेळात हीट ट्रान्सफर होईल. याच्या जागी तुम्ही जर ब्रिक घेतली तर त्यामध्ये जास्त टाइम लागतो हीट ट्रान्सफर व्हायला. सो that property will decide the transfer of heat. It is called as thermal conductivity. So it is shown here. So air has very poor thermal conductivity. Hence, rate of heat transfer from vapor to cooling medium is reduced. आता नवीन तुम्ही जर ब्रिक्स बघितल्या बिल्डिंग मधल्या काय काय तुम्ही जर व्हिडिओ बघा किंवा बघताय, आधी कशा सॉलिड ब्रिक होत्या, म्हणजे आतून बाहेरून तिथे एकच मटेरियल होतं. तर नवीन ब्रिक्स मध्ये काय केलं त्यांनी, आत एअर पॉकेट्स तयार केले. ठीक आहे, असे एअर पॉकेट्स. आणि ह्याच्यामुळे काय होतंय, ब्रिकचं वजन देखील कमी होतंय. अँड एअर हॅज पुअर थर्मल कंडक्टिव्हिटी. सो हीट ट्रान्सफर फ्रॉम आउटसाइड टू इनसाइड reduces. So that is the advantage of this new bricks. लाईट वेट पण आहेत आणि हीट ट्रान्सफर कमी होते. बाहेर किती जरी टेम्परेचर असलं तरी आत तेवढं आपल्याला जाणवत नाही. That is the beauty of this. Okay. And the presence of air in the condenser corrodes the metal surfaces. Therefore, the life of condenser is reduced. Okay. Air has some particles into that, and that their erosion takes place. Because of that, the life of condenser is reduced because of particles in the air. Okay, so that is the last point, effects of air leakage. And this, with this chapter is over. Condenser chapter is over. In next lecture we start the reciprocating air compressors. Okay. Here, what is the time? 2:15. So I will give you some test, MCQ test. So please solve it. Okay, shall I give? So I'll give MCQ test. अच्छा ह्यात टाकू का चॅट बॉक्स में टाकू हाँ देख ज्वाइन आउट so link for the quiz is given in the chat box so those are in online mode please click on the link and then you can join the quiz. So with this we'll stop here. The next lecture will start the reciprocating air compressors and please join the quiz and attend. Thank you.